Concentrations and titration calculations for Cambridge IGCSE Chemistry. Cambridge requires knowledge of different units of volume and of concentration, how to calculate concentration in moles per decimeter cubed, and then how to use the concentrations in titration calculation. So most measurements of volume in the chemistry lab are made in centimeters cubed. For instance, you'll be familiar with a measuring cylinder measuring out 25 centimeters cubed. However, calculations generally involve dm cubed, decimeters cubed. 1000 centimeters cubed is equal to 1 decimeter cubed, 1 dm cubed. So 25 centimeters cubed is equal to 0.025 dm cubed. How do I achieve that? I divide 25 by 1000. To turn centimeters cubed into decimeters cubed, I divide the number of centimeters cubed by 1000. Okay, so try converting the unit for these volumes. 50 centimeters cubed, how many dm cubed? 100 centimeters cubed, how many dm cubed? And 0.25 dm cubed, how many centimeters cubed? Stop the lesson, do the calculation, come back to check when you are ready. So I'm about to reveal 50 centimeters cubed. We divide by 1000 to achieve 0.05 dm cubed. 100 centimeters cubed divided by 1000 gives you 0.1 dm cubed. But to turn decimeters into centimeters cubed, I hope you've worked it out. If not, here we go. 0.25 decimeters cubed times 1000 gives you 250 centimeters cubed. The number of dm cubed is always going to be smaller than the number of centimeters cubed. So the numbers of dm cubed is going to be smaller than the number of centimeters cubed. So we multiply by 1000 to go from dm cubed to cm cubed, but from centimeters cubed we divide by 1000. You will need that in titration calculation. So let's look at the two units of concentration, grams per decimeter cubed and moles per decimeter cubed. So the simplest is obviously just the mass of solute divided by the volume of solution, grams per dm cubed, so volume in decimeters cubed. However, calculations generally involve moles per decimeter cubed. So you're going to have to convert between the two units. To do that, you simply recall that the numbers of moles is equal to the mass, in this case of solute, divided by the molar mass of that solute. So convert the concentrations of sodium hydroxide solution in this table. We've got 2 in grams per decimeter cubed and 1 in moles per decimeter cubed. Can you convert them into their counterpart concentration? Stop the lesson, try those conversions, come back to check when you are ready. Okay, so let's have a look at the first one. Well, we've got 4 grams. We need to convert that into moles. So that's 4 divided by 40. The relative molecular mass of sodium hydroxide is, of course, 40. So that equals 0.1. So our concentration is 0.1 moles per decimeter cubed. The second one, well, that's going to be 10 divided by 40, which is obviously 0.25. So our concentration is 0.25 moles per decimeter cubed. But what about the final one? Well, this time we need to do 0.05 times 40. And that comes to 2 grams per decimeter cubed. The mass is moles times molar mass. Bring molar mass up here. So mass is molar mass times numbers of moles. numbers of moles times molar mass gives you the mass. It's a rearrangement of this equation. How to calculate concentrations in moles per decimeter cubed. So interpreting raw data, the key expressions are, of course, that the numbers of moles is the mass of solute divided by its molar mass, and that concentration is, of course, moles divided by the volume in decimeters cubed. So let's take an example. Calculate the concentration of the solution formed when 6.3 grams of hydrogen nitrate is dissolved in 500 centimeters cubed of water. So I'll walk you through this. The moles of solute would be 6.3 divided by 63, which is the molar mass of hydrogen nitrate. 1, 14, and 3 times 16 comes to 63. So we have 0.1 moles. But we also need to convert the volume, 500 centimeters cubed, into decimeters cubed. So 500 divided by 1000, 0.5 decimeters cubed. Now, our concentration is, of course, moles divided by volume. So moles divided by volume, 0.1 divided by 0.5 comes to 0.2 moles per decimeter cubed. So standard procedure, convert the mass of solute into a numbers of moles, convert the volume, if it is in centimeters cubed, into decimeters cubed, divide the numbers of moles by the volume to give you the concentration in moles per decimeter cubed. If you are confident about these calculations, just skip ahead a couple of slides. Otherwise, try to calculate these three missing values. Concentration of sodium hydroxide given a volume and a mass, the mass of hydrogen sulfate given a volume and a concentration, and the volume of calcium oxide solution given the mass and the concentration in grams per decimeter cubed. Stop the lesson, try the three calculations, come back to check your answers when you are ready. Okay, so I'm going to reveal. The first answer is 0.1. Where does this come from? Well, I calculate the numbers of moles as being 0.2. And the volume, of course, is not 2000, but 2 decimeters cubed. So the concentration is moles divided by volume comes to 0.1. For the second problem, we come up with 9.8 grams. Where does that come from? Well, the moles of sulfuric acid is going to be the concentration times the volume. So the mass will be numbers of moles, so 0.1 moles. So 0.1 times the molar mass, which is 98. Sulfuric acid, 2, 32, and 64 comes to 98, comes to 9.8 grams. Here we're going to do concentration is 12 grams per decimeter cubed, so that's 3 divided by an unknown volume x. So 12 times x equals 3. X must equal 0.25, but that will be in decimeters cubed, trick question. So that's 250 centimeters cubed. How to carry out a titration calculation. So the first key idea is that of reacting mole ratio, which is the ratio of moles of each substance reacting and being formed in a chemical reaction. So in a balanced equation, we include this reacting ratio in moles. So this equation, 1 H2SO4, 1 mole of H2SO4 reacts with 2 moles of sodium hydroxide to form 2 moles of water and 2 moles of aqueous sodium chloride. This mole ratio, 1 to 2 to 2 to 2, is fixed regardless of the actual amounts involved. It will always be a ratio of 1 mole to 2 moles to 2 moles to 2 moles. So in titration, there are 4 values that you have to manipulate: the volume of alkali and the concentration of alkali, often found in the conical flask, and then the volume of acid delivered from the burette and the concentration of that acid. And we want to know their values at exact reaction, that is when the indicator changes color. If you have 3 of these values, the 4th, the unknown value, can be calculated. That is the key idea in titration calculation. So let's look at an example titration calculation. This is the sort of data you get. Calculate the concentration of dilute hydrochloric acid given that 35 centimeters cubed reacted completely with 25 centimeters cubed of 2 mole per decimeter cubed sodium hydroxide. So we have 1, 2, 3 values. We need to calculate the 4th. So we have a balanced equation with a reacting mole ratio of 1 to 1 to 1 to 1. So it's a simple 1 to 1 ratio throughout. We're going to use a triangle to help us remember how to calculate moles, volume, and concentration. So moles is equal to volume times concentration. So the moles of sodium hydroxide is the concentration times the volume. The concentration is 2 moles per decimeter cubed. The volume is not 25, it's 0.025 because it's got to be in decimeters cubed. So that gives us 0.05 moles of sodium hydroxide. Well, because it's a 1-to-1 reacting ratio, that would react with exactly that numbers of moles of hydrochloric acid, 0.05. Now we want to work out the concentration of the hydrochloric acid. Well, the concentration will be moles divided by volume. Moles divided by volume. So moles, 0.05. Our volume, back to the question, 35 centimeters cubed, but 0.035 decimeters cubed. So that comes to 1.3 moles per decimeter cubed. The concentration of hydrochloric acid, 1.43 moles per decimeter cubed. So here's a problem for you to try. Calculate the volume of 0.5 hydrochloric acid that reacts exactly with 25 centimeters cubed of 1 mole per decimeter cubed sodium hydroxide. Here's the equation. Of course, it's a 1-to-1-to-1 mole ratio. See if you can calculate the volume of hydrochloric acid that would completely react with that volume of sodium hydroxide at that concentration. Stop the lesson, carry out the calculation, come back to check when you are ready. Okay, so I'm going to reveal. Here's my triangle. Numbers of moles is volume times concentration. So I work out the moles of sodium hydroxide, concentration times volume. The moles of hydrochloric acid that are reacting is the same because it's a 1-to-1 ratio. The volume involved is unknown. So volume is moles divided by concentration. Moles divided by concentration. So moles divided by concentration, 0.025 divided by 0.5 moles per decimeter cubed. So the volume is 0.0125 decimeters cubed, which comes out as 12.5 centimeters cubed. So one last variation. Calculate the concentration of dilute sulfuric acid given that 15 centimeters cubed reacted completely with 25 centimeters cubed of 1 mole per decimeter cubed sodium hydroxide. Well, what's different? The reacting mole ratio. 1 mole of sulfuric acid reacts with 2 moles of sodium hydroxide. You're going to have to use that in the calculation. So stop, carry out that calculation, come back to see if you've got it right and correct if necessary. when you are ready. Okay, so I'm hoping you've carried out the calculation. That's the point of the lesson. I'm going to reveal. Obviously, the triangle is going to help me out and work out the moles of sodium hydroxide. Volume times concentration is numbers of moles. So 0.025 moles of sodium hydroxide, 25 at 1 mole per decimeter cubed. But the reacting moles of sulfuric acid are not 0.025. It's 0.025 divided by 2. The moles of sodium hydroxide are twice the amount of sulfuric acid. So the moles of sulfuric acid is 0.025 divided by 2 comes to 0.125. Then it's plain sailing. The concentration is moles divided by volume. Moles divided by volume, 0.0125 divided by 15 centimeters cubed in decimeters cubed comes out as 0.83 moles per decimeter cubed. Congratulations if you got that right. There is a separate chemistry class on titration technique within the playlist. A full playlist is linked in the video description. Try some past paper questions. The PMT Physics Maths Tutor website has unlimited past papers. If you found this class helpful, please recommend it to a friend. Please like and subscribe. And a comment, always appreciated.